Hello, today we're going to continue working on lesson 10, comparing functions, and this is page 20. We're going to finish with 6, 8, and 9, and then I'm going to ask you to work on the independent practice sheet. So let's get started. Julie's family is filling up the pool in her backyard. The equation y equals 5 and 2/10 x plus 8,400 can be used to show the rate at which the pool is filling up with water, where y is the total amount of water in gallons and x is the amount of time in minutes. Her neighbor, Elena, is also filling up their pool as shown in the table below. The question is, whose pool is filling up at a faster rate and how do you know? So let's go back and highlight some important information. What do we think is important there? Well, Julie is filling up her backyard pool, and her information is represented with this equation. And this equation is in slope-intercept form. They go on to let us know that y, okay, and we're looking for the change in y over the change in x, is the total amount of water in gallons, and x is the amount of time in minutes. Next, it says her neighbor Elena's information is in this table. So let's start with Julie's information. And Julie's information is given an equation, and if you recall, we have y equals mx plus b, and this equation is in that form. M is the slope or the rate of change. So if we look at this, this is the rate of change. Now we need to put some meaning to that. Rate of change would be also like a unit rate, and so y is the total amount of water in gallons and x is a minute. So if we think about it like this, change in y over the change in x, and we have 5 and 2/10 over 1. This means this is 5 and 2/10 gallons in 1 minute. So her rate of change is 5 and 2/10. And this is Julie's information. Now let's look at Elena. Elena's information is given in a table. So we're going to start with Elena's information. We have y over x, change in y over change in x. So we're going to start here. This always feels a little bit awkward because we're working with the bottom part of the table. So we're looking for the change here over the change in our x values. So this would be a good place to have your calculator. If I'm looking, I can see that it's going up. I'm going from 7,850 to 7,864 and 4/10. So this is where they're using the formula. If we take our second y minus our first y, that would be helpful. So 7,864 and 4/10 minus 7,850, and we're going to get 14 and 4/10. So our change in y for the first is 14 and 4/10. And now we're going to look in the change of our x's. That's 3. And now we're going to have to go and find the change from this y to this y value, and from this x to this x value. And for the sake of time, I'm just going to ask you to take this in your calculator minus this, and you should get 9 and 6/10, and the change from 3 to 5 is 2. And then you're going to go ahead and do it for the last. You're also going to get 9 and 6/10, and you're going to get 2. Now you may have noticed these are all not the same. These two are, and this is not. So what you're going to need to do is take the top number divided by the bottom number in each one, and you should get a constant rate, which is 4 and 8/10 over 1. Or what your calculator will say 4 and 8/10. And what this is 4 and 8/10 gallons for 1 minute. So her rate of change is 4 and 8/10. So if I look at this now, the question was, whose pool is filling up at a faster rate? And how do you know? Well, Julie's pool is filling up at a faster rate per minute. She's able to fill it with 5 and 2/10 gallons every minute, while Elena is filling it with 4 and 8/10 gallons. So let's write that Julie's pool is filling up at a faster rate. And that's because it's 5 and 2/10 compared to 4 and 8/10. Okay, let's move on to number 8. Number 8 says compare the slope of the equation y equals 3/5 x plus 2 with the slope shown in the ordered pairs, which has a greater rate of change. So like we did just a few minutes ago, we're going to go ahead and say that this is the rate of change, 3/5. That's the slope or the rate of change. And then I would suggest, I think this might be easier if we put those ordered pairs, I put the ordered pairs into a table. Make it a little bit easier to find the rate of change. So I have 1 with 2 and 6/10, 3 with 3 and 8/10, 5, 5, and then 7 with 6 and 2/10. So now we're going to try to find the rate of change. I'm going to find the change in my y's from 2 and 6/10 to 3 and 8/10 would be 1 and 2/10. And then from 3 and 8/10 to 5 would also be 1 and 2/10. And this should be 6. And from 5 to 6 and 2/10 would be 1 and 2/10. So it's a consistent change. And if we go from each of these, we're going to get a change of 2. So in your calculator, please take 1 and 2/10 divided by 2. When you do that, you're going to get 0 and 6/10. So now we're trying to compare an answer in decimal form and one in fraction form. So let's go back and recall that 6/10 can be written like this as a fraction, and then it can be reduced. If I divide both the top and bottom by 3, I'm going to get 3/5. So the rate of change is the same. All right, and our last situation is number 9. Reese and Kevin have been working out together and trying to lose weight. Reese's weight loss can be modeled in the equation y equals negative 4x plus 203, where y is his total weight and x is the number of weeks he's been working out. Kevin's weight loss progress is shown in the graph below. Who is losing weight at a faster rate? Explain your reasoning. So let's begin again with Reese's information. So Reese is losing weight, and his is modeled with an equation. And they tell us y is his total weight, and x is the number of weeks. Now let's go on to Kevin's information. Kevin is losing weight in the table. So everything, is in the graph. So all of Kevin's information is in the graph. Okay, so Let's start with the equation. And once again, they're giving us slope-intercept form. So this is the weight loss right there for Reese. And I see a -4, and they tell me that that's the weight. And remember, this is like a unit rate for 1 per 1 week. So Reese's weight loss is 4 pounds per week. So every week, that's his rate. Now let's look at Kevin's weight loss. Kevin's is represented in the table. So if I look at this line, we're going to try to find some points. Here's a point. And it looks like here would be a point, and that's the only ones given on the graph. So if we look at this, we're going to use the rise over run. So Kevin is going to be represented by the rise, change in y's over the change in x. So I'm going to go down, and you notice that the scale is in increments of 20, a scale of 20. So it's going down, so that's -20. And then we're going 1, 2, 3, 4 boxes, but let's look. Okay, and it is the scale of 1. So we're going to use that 4. And this can be reduced to -5 over 1, a -5. So this means that Kevin is losing 5 pounds per week. So the question is, who is losing weight at a faster rate? And explain your reasoning. Well, Kevin is losing at a faster rate. At 5 pounds per week compared to Reese's 4 pounds per week. Okay, thank you for listening. And calculator would be a good idea to have handy for these. And I'd like you to go ahead and work on the independent practice sheet the next lesson. Thank you. Bye-bye.